Hi and welcome to this A-level maths lesson, which I'm entitling Core Algebra. So this session will be a whistle-stop tour of all the core algebra concepts you need for A-level maths. I will be going through things incredibly quickly because this is stuff that if you're doing A-level maths, you should be super duper familiar with, but I want to make sure that it is super reinforced for you all. So we will be having a look at completing the square. We will be having a look at inequalities. We'll be having a look at some graph stuff and the discriminant as well. So it's going to move really, really quickly. There is a worksheet that accompanies this session. I highly encourage you to go and have a go at that. They are all past exam questions and they also all have worked solutions. You can find the link to that worksheet in the description for this video. It's entirely free and will be massively useful. At the end of the day, maths is all about practice and application. So the more that you practice the concepts, the better you will be. So starting off, to solve simultaneous equations. Again, you should be super familiar with solving simultaneous equations to the point where I'm not going to go through solving linear simultaneous equations. You should be super familiar with that now. We are going to have a quick look at solving quadratic simultaneous equations. Let me share my magic whiteboard so I can give you a simultaneous equation that we are going to solve. So if I was asked to solve the simultaneous equations, x plus 2y is equal to 3 and x squared plus 3xy is equal to 10. Now, with linear equations, there are two methods that you could use to solve them. You can use elimination or substitution. For quadratic simultaneous equations, substitution is your only option. Now, for substitution, you need to rearrange the first equation, the top one, the linear one, to make x or y the subject, and then substitute it into the second one. Now, it doesn't matter whether you pick to make x or y the subject. I always choose the one that doesn't have anything times by it, if that's an option, because then I don't end up with fractions and dividing and all that kind of stuff. So I'm going to rearrange this first equation to be x is equal to 3 minus 2y. I am then going to substitute that into the second equation. So wherever I see an x, it's going to become 3 minus 2y. So substituting that in, I'm going to get 3 minus 2y squared plus 3 minus 2y times y is equal to 10. Now all I need to do, now what we need to do is expand all the brackets and collect together the like terms. So if I expand that first bracket, I'm going to get 9 minus 6y minus 6y plus 4y squared onto the second bracket plus 9 minus 6y all times y is equal to 10. If I keep going, then I've got 9 minus 12y plus 4y squared plus 9y minus 6y squared minus 10 is equal to 0. If I keep going, then I end up with 9 minus 10 is minus 1, 12y plus 9y is minus 3y, and 4y squared minus 6y squared is minus 2y squared is equal to 0. What I can then do is times everything by minus 1, so I end up with 2y squared plus 3y plus 1 is equal to 0. I'm going to add a new page to solve that. So I had 2y squared plus 3y plus 1 is equal to 0. I can then factorize that. So 1 times 1 is going to give me 1. I'm going to have a 2y and a y, and then add those, and that's going to be equal to 0, which means y is going to be equal to negative a half, or y is going to be equal to negative 1. And here is the bit where people lose their marks. You have found y. It has been a slog. You have managed to solve the quadratic. Do not forget to go back and substitute that into the original equation to find x. And if you're going to do that, substitute into the linear one. Don't substitute back into the quadratic. So our linear equation was x plus 2y is equal to 3. So substituting in for minus a half, x was equal to 3 minus 2y. So 3 minus 2 times minus a half is going to be x is equal to 4. And this one, x is going to be equal to 5. And that's it. I told you it was going to be quick. That is a quick recap of how to solve quadratic simultaneous equations. Now on to my favourite thing of all, inequalities. Now, inequalities do not take loads of explanation, but they are also one of those areas that everyone always seems to struggle with. Now, linear inequalities, for example, let me get up an example. If I have 2x minus 3 is less than 7, solve that as if it was an equals. So 2x is going to be less than 10, and so x is going to be less than 5. That's it. We treat it exactly the same as an equal sign. The only thing that needs to happen is if you divide by minus 1 or a negative number, you flip the inequality. But in general, linear inequalities are super duper simple. It's the quadratic ones that seem to throw people. So if I have, let's pick a nice one. Let's say that x squared minus 11x plus 24 is less than 0. Now we're going to solve that quadratic as if it was equal to 0, okay? So numbers that make 24, so that's going to be x minus 8 and x minus 3. Which means that my roots, if I was to draw the graph of this, would be x equals 8 or x equals 3. Now, for quadratic inequalities, it is all about the sketch. You're going to sketch the graph. Admittedly, my sketching is not great, but that's why I love the word sketch, because it means it doesn't have to be. So the quadratic graph is going to be a smiley face. I'm drawing with my finger, so it's not that neat either. And we are looking for the region of the graph that is below 0. So we look for the bit that is underneath the x-axis. That is this region underneath here. And for that region, x is between 3 and 8. So we say 3 is less than x, which is less than 8. If I was looking for greater than 0, it would be every other value. Okay. So for example, if we did another one, if we had to go at x squared minus 3x minus 10 is greater than 0, factorising that is going to give me x minus 5 and x plus 2, which is x equals 5 and x equals minus 2. And again, it's all about the sketch. So you've got minus 2 and you've got 5. You've got your graph going through there. And this time we're looking for the regions that are greater than 0, which is when x is less than minus 2 an x is greater than 5. It's the outer regions. And that sketch takes 3 seconds. If I can do it on this whiteboard, you can do it in a test. It takes a matter of seconds, and it just helps you to remember which region you're interested in. And that's it. There is nothing more difficult about inequalities. And again, the worksheet has practice on this. So I highly encourage you to download it and have a go. There are solutions for the worksheet as well. So we've done simultaneous equations, we've done inequalities. When lines intersect and the discriminant are the two things that I want to make sure we've also covered. So when lines intersect, if I have two graphs that intersect, so for example, if I have, let me get a quadratic up. If I have two x plus y is equal to 3, that's one graph, and y is equal to x squared minus 3x plus 1. These are just simultaneous equations, right? We can make this top one the same as y is equal to 3 minus 2x. And then we can say 3 minus 2x is equal to x squared minus 3x plus 1. Which is the same as saying x squared minus x minus 2 is equal to 0. I think I've rearranged that right. Plus 2x and minus 3. Yep. Does that factorize? Yep, it does, because we can have minus 2 and plus 1 equals 0, which means x would be equal to 2 and x would be equal to minus 1. Those are the x coordinates of the points of intersection of those two graphs. And I can solve that without having to draw or sketch the graphs. Don't draw or sketch them in this scenario unless you're asked to. Solve them as simultaneous equations. And then remember to substitute back in to find y. So in this case, y is going to be equal to minus 1. And in this case, y is going to be equal to 5. And there you have it. Our coordinates are 2, minus 1, and minus 1, 5. Intersections of graphs. All done algebraically. Talking about graphs, now, if you are at the start of A-level maths, you may not have learned differentiation yet. If you are partway through A-level maths, you will have definitely heard of differentiation. Now, differentiation is used to find the gradient of a graph, and we can use that to find the stationary points, the turning points of a graph. For a quadratic, though, we can also find that by completing the square. And completing the square becomes particularly important when we come to circle graphs. So just as a reminder for completing the square, if I have 3x squared plus 6x plus 1, and I'm asked to write that in the form, it's always like ax squared plus b plus c. The first thing I'm going to do is take out any number in front of the x squared. So I'm going to rewrite that as 3x squared plus 2x, and then tag the number on the end. And again, you should be familiar with completing the square, but it's the one that everybody always forgets because it's only relevant in a really small number of very niche scenarios, which is why it gets forgotten. So it's good to revise it and have a quick practice of it. And again, there's practice in the worksheet for you to have a go at. It's not a lengthy worksheet, it's only 5 questions, but it covers quite a lot. So carrying on, we then want to make that bracket a square. So we make that x plus half of whatever's in front of the x. So x plus 1 squared minus 1. That's all still multiplied by 3 plus 1. The minus 1 comes from x plus 1 squared would give you x squared plus 2x plus 1. But in the bracket, we only have x squared plus 2x. So that's where that comes from. And then if we expand that out, we get 3x plus 1 squared minus 3 plus 1 is minus 2. And that's it. And we would, if we wanted to be extra sure, we would write a equals 3, b equals 1, and c equals minus 2. Again, I told you it'd be quick, but that is a reminder of completing the square. Final thing, absolute final thing, the discriminant. The discriminant comes up so often. If you remember the quadratic formula, which you all should by this point, then the quadratic formula, the bit in the square root, you have minus b plus or minus the square root of b squared minus 4ac. That is the discriminant. It tells us how many roots an equation is going to have. So if it is greater than 0, it will have 2 distinct real roots. If it is equal to 0, you will get 1 repeated root. And if it is less than 0, then you have no real roots, which makes sense because you're square rooting. And if it's less than 0, then you're trying to square root a negative number. So you have no real roots. And if you are asked to prove that an equation has no real roots, then you need to make the discriminant less than 0. And that is a classic exam question that comes up. Now, there is an example of that in the worksheet. It's fairly straightforward, but I really encourage you to have a go because it's one of those subtle things that people just seem to gloss over, and it comes up and it's really, really important. So I thoroughly encourage you, I'm going to stop talking now, but I thoroughly encourage you to have a go at using the discriminant in that worksheet question. I know that was very quick, but I want these lessons to be short and snappy and to the point. So that is a very, very, very speedy recap of some of the core algebra that you will need for A-level maths. I hope you found that useful. Please provide feedback in the comment section. Tell me if there are any topics you want to see covered. I hope you all found that useful, and I will look forward to seeing you next time. Thank you for watching. Have a great day. Bye.